Hey everyone, and welcome! Today, we're looking at a Leetcode problem that sounds simple but has a really elegant mathematical solution. It's a game theory puzzle about picking flowers. Let's break it down together. So here's the official problem description. I won't read it all to you, but let's go over the main ideas on the next few slides so we're all on the same page. The setup is pretty straightforward. We've got our two players, Alice and Bob. The game is played on a field with two separate lanes, or rows, of flowers. The number of flowers in each lane is what we'll call X and Y. The rules are simple. Alice always starts. On your turn, you just have to pick one single flower. You can choose to take it from the first lane or the second lane, but you can only take one. This is a classic last move wins type of game. The player who picks the very last flower off the field is the winner. The game ends when all the flowers are gone. So here's the actual puzzle. We're not just playing one game, we're given ranges for the number of flowers. The first lane can have anywhere from 1 to n flowers, and the second can have from 1 to m flowers. Our job is to count how many of these starting combinations of X and Y will result in a guaranteed win for Alice. Okay, let's walk through the example from the problem, where n is 3 and m is 2. This means X can be 1, 2, or 3, and Y can be 1 or 2. Let's just pick one of those possible starting setups and see what happens. How about starting with one flower in lane 1, and 2 flowers in lane 2. The total number of flowers is 3. Since players take one flower per turn, this means the game will last for exactly 3 turns. Alice goes first, on turn 1. Bob goes second, on turn 2. And then, it's Alice's turn again for the third and final turn. She takes the last flower and she wins. So the pair 1-2 is a winning setup for Alice. We should count this one. Wait a second, did you see the pattern? Alice always gets the odd-numbered turns, and Bob always gets the even-numbered ones. To win, a player has to make the last move. For Alice to win, the total number of turns must be an odd number. And that's the whole secret to the game. The specific lanes don't matter, only the total count. If the sum of X and Y is an odd number, Alice wins. If the sum is even, Bob wins. Our big game theory problem just became a much simpler counting problem. So how do we get an odd sum from two numbers? There are only two ways. Either the first number is odd and the second is even, or the first is even and the second is odd. We just need to count how many pairs fit these two descriptions. So our strategy could be to count the number of odd choices for X, and multiply that by the number of even choices for Y. Then, we do the opposite, count the even choices for X, and multiply by the odd choices for Y, plig X. Adding those two products gives us the total. But, as the editorial points out, there's a beautiful mathematical shortcut. Believe it or not, this one line of code is the complete solution. It returns m times n, with an integer division by 2. Let's quickly talk about why this amazing simplification works. Okay, so imagine all the possible pairs. There are n choices for the first number, and m choices for the second, giving us a total of n times m combinations. It turns out that across all these combinations, the number of pairs that sum to an odd number is almost exactly half of the total. Integer division, that's the double slash, correctly handles both cases where the total product is even or odd, giving us the floor of the result. This is exactly the count we need. It's a fantastic trick. So how efficient is this? Well, we are just performing one multiplication and one division. These operations take the same amount of time, regardless of how big n and m are. This is called constant time, or big O of 1. And since we don't need any extra storage, the space complexity is also constant, big O of 1. This is as fast as it gets. Alright, let's wrap it up. The biggest takeaway here is to always look for the underlying pattern in a game. We found that the winning condition was simply having an odd total number of flowers. This turned the problem into a much easier counting exercise, which we then solved with a super efficient one-line formula. I hope this breakdown made the solution clear. If you found this helpful, please hit the like button, subscribe for more Leetcode explanations, and feel free to ask any questions in the comments. And hey, if you're feeling extra generous, there's always the Boba Fund. Thanks for watching, and happy coding.